Hi everyone. Today is our fourth and final conic that we're going to look at initially, and this one is the parabola. Now you may have studied parabolas before in the form of what we call quadratics. Now quadratics are parabolas of a certain type. They are parabolas that happen to be functions. Parabolas can open up and down like quadratics do, but they also can open left and right. We're going to approach the parabolas like we approach the other three conics. We're going to look at the definition. We're going to look at a graph of a parabola and its key components. We're going to look at the formulas. We're going to find the features from the formulas, and then we will convert from general form into graphing form by completing the square. And this completing the square is slightly different than the last one. So let's start with the definition. The definition of a parabola is the set of all points that are the same distance from a fixed point and a fixed line. Stop the video and write that down if you need to. The parabola is the set of all points that are the same distance from a fixed point and a fixed line. The fixed point is called the focus, and a parabola only has one. And the fixed line has a new name. It's called a directrix. It's the word direct and then add an RIX to the end. So every parabola has a focus and a directrix that determine the shape of the parabola. Now I do have another GIF to show you, similar to the last one that we looked at. And this one talks about the way the parabola looks. As you can see on the screen, here is a focus. There's the directrix, and notice that the length between the focus and the curve and the directrix and the curve is constant. Let's watch it again. Focus, directrix, perpendicular. The midpoint is the vertex. The lengths are equal, and as you move up the parabola on either side, those lengths stay equal to each other, and that's what makes a parabola work. So we will draw one here in a minute. This is a parabola that opens up as opposed to the ones that open sideways. Let's now draw a picture of a parabola so we can take a look at what they look like. So we're going to draw a pretty good size one right here. We're going to have this parabola opening to the right. So I'm going to put its starting point here, and I'm going to have it open to the right. Now, the starting point is not always on the x-axis or the y-axis. It could be anywhere in the xy plane. Now this starting point here is called the vertex. A parabola does not have a center. It has a single vertex. The two key features on the parabola are the focus, which I tend to use a letter X to denote, and then it has a directrix, which is a dotted line, partially because it's really not part of the graph. It's just a measuring tool. And it's not even an asymptote because it doesn't get really close to it. So here is my focus, and here is my directrix. Now there is not an A measurement or a B measurement here. There is only a C measurement. And the C measurement is from the vertex to the focus and the vertex to the directrix. They're both equal to C. If you remember from the GIF that we looked at, it showed that those two were equal lengths. So C, and I'm going to make a note of this here, C is also called the focal length. So when you see the focal length referred to in a textbook, they're talking about how long C is. Some books use different variables for that focal length, but we use C because it's always been the distance from the starting point to the focus. Now, there are a couple of other key features that I want to talk about, specifically a line that the directrix and the focus and the vertex are all on. In this case, it happens to be the x-axis. This is called the axis of symmetry. Now usually you will not have to find the axis of symmetry. It's just a point that we wanted to make you aware of, that it's a line that basically if you folded the parabola over it, it would match up on both sides. And it makes it easier to graph because if you graph the points on one side of the axis of symmetry, you can quickly find the points on the other side. So I'm going to save the last key feature for later, and I want to talk about the 5 key components that you are going to need in order to find the information for a parabola. So I'm going to call these the 5 key components, or the 5 key features that I'm going to ask you to look for. The first one is the vertex. And I'm going to go back to my diagram here, and I'm going to label it as H and K, and it's been H and K all along. So the second thing you need to find is C. C is a very easy thing to find from the equation. Once we write the formula down, you will see how easy it is to find. And once again, C is equal to the focal length. I'm going to put that there. Now the third one is one that the books don't really ask for, but it's very helpful in finding the last 2. And it's called the direction of opening. The direction of opening. Now, this specific parabola that I have drawn opens to the right. And notice that the 2 branches are pointing to the right. That's why I call this an opening right parabola. Number 4 is the focus's location, and number 5 is the directrix location. In your textbook, they will probably ask you for all of them except for number 3. But number 3 makes finding 4 and 5 so much easier. All right, now let's talk about the formulas that you need. First of all, general form. And guess what? General form is the exact same general form as it was before. AX squared plus, I messed up, plus CY squared plus DX plus EY plus F equals 0. Now, let's kind of review for a minute. Circles, A and C are the same. Ellipses, A and C are different, but they're the same sign. Hyperbolas, A and C are opposite signs. And for a parabola, either A equals 0 or C equals 0. What makes a parabola work is that both variables are not squared. Only one of them is. So the other term, the A term or the C term, will be missing. The D, E, and F terms will probably be there, but either the A term will be missing or the C term will be missing. Number 2, graphing form. And there are 2 graphing forms that we're going to talk about. The first one looks like this. X minus h, the quantity squared, equals 4c bracket y minus k. X minus h, the quantity squared, equals 4c bracket y minus k. Now, because x is squared and y is not, c will either determine whether the parabola opens up or down. If c is greater than 0, the parabola will open up. If c is less than 0, the parabola will open down. All right, the second form has the 2 brackets switched, so it would be y minus k, the quantity squared, equals 4c bracket x minus h. So if y is squared, c is positive, the graph will open to the right. If c is negative, the graph will open to the left. All right, so stop for a minute. Look at the graph at the top of the page that we drew. Which form is it in, and what sign is C? Since this one opens to the right, it matches this form, so y is squared and c is positive. So we're going to practice taking equations in these forms and finding the pertinent features that we need to find. So I'm going to change pages. Let's do an example in graphing form. The directions will usually say find the vertex, focal length, focus, and directrix. That's 4 things. 4 out of the 5 that we listed. Remember that focal length is C, so they're looking for C in that regard. Now, you probably are going to have to call it focal length when you note it. You also want to write down which way it opens, and I'll show you why as we do the problem. So let's do the first one. We're going to take y minus 7, the quantity squared, equals negative 20, bracket, x plus 1. So I'm going to list my components that they want over here. The vertex. Now be very careful. Once again, insiders lie. Is it 7, negative 1, or is it negative 1, 7? The answer is it is negative 1, 7, because x has to come first. All right, the next thing I want is c. Now c happens to be what? Well, let's go back and look. Look at your equation right here. Notice that this number that's on the right-hand side in front of the bracket that is not squared is 4 times c for both forms. So that number is your key to finding c. My 4c number here is negative 20. So c would be negative 20 divided by 4. So in this case, it is negative 5. So the focal length is negative 5. The next thing I want you to write down is the direction of opening. Okay? So the two things that determine the direction of opening are which variable is squared and what sign c is. So y is squared, c is negative. So I'm going to go back to the previous page. Look at these two. Y is squared, c is negative, so it's opening to the left. So I'm going to write that down. It opens to the left. Now that is basically extra information that's going to help us find the focus and the directrix. So the focus is the next piece of information I want to find. Now the focus is a point, so it's going to be an ordered pair, x and y. So off to the side here, I'm going to write down how this time to find the focus. You're going to move c units from the vertex in the direction of opening. I'm kind of abbreviating a little bit. To find the focus, you move c units from the vertex in the direction that it opens. So here's my vertex. I'm going to go 5 units. I'm going to, even though that says negative, I want to think about it as 5. 5 units to the left of the vertex. I need to find where that's going to be because that's where the focus is going to be. So think about it for a minute. If I am moving left, which variable is changing, x or y? The answer is x. X is changing. My focus is going to be negative 1 minus 5, comma 7, because the x is moving to the left. Left is negative. So this will change to be negative 6, comma 7. Now, you do not have to write this extra step here. I think of it as a way to show you how I got this answer. Let me talk about one more thing. Let's go back to the picture. Look where the focus is in relationship to the curve. The curve opens to the right, and the focus is to the right. So the focus and the direction of opening are always the same. So if it opens right, you will move right to get to your focus. If it opens left, you'll move left, up moves up, and so on. You get the point. Okay, now for the directrix, you're going to move c units from the vertex in the opposite direction. So whichever way you moved for the focus, you move the opposite way for the directrix. Now remember also that the directrix is a line. It is either a vertical line or a horizontal line. Okay? So I know it's going to be x or y equals a number. Okay? Now, how do I know whether it's x or y? I'll talk about it 2 different ways. Notice that this picture is y squared, which is the one that we drew. This is a y squared. graph right here. Which way is the directrix? It is vertical. Are vertical lines x equals a number or y equals a number? They happen to be x equals a number. So this is going to be, because it's opening left, just like the other one's opening right, and y is squared, this is going to be an x equals line. And instead of it being -1 minus 5, it's going to be -1 plus 5. So the directrix is the line x equals 4. Here's another thing that I just noticed today as I was making these notes to kind of help you out. To know what letter to put right here, look at what variable changed for your focus. If the x changes for your focus, it's going to be an x equals line. If y changes for your focus, it's going to be a y equals line for your directrix. So I'll say that again when we do the next problem. Since x changed, the directrix is x equals. If y had changed, y equals would be the directrix. So I have now found my 5 key features. My 4 key features. The vertex, the focal length, the focus, and the directrix. Those are the 4 pieces of information that they wanted. All right, now it's your turn. So try number 2. The equation is x plus 2 the quantity squared equals 8 bracket y plus 6. X plus 2 the quantity squared equals 8 bracket y plus 6. I want you to find the same pieces of information that I found in the previous problem. Pause your video, do the work, and when you come back, we'll take a look and see if you got the problem right. Okay, here are our answers. The vertex is -2, -6 from these 2 brackets right here. C is equal to 8 divided by 4. You always divide by 4, so your C value is 2. This one is opening upwards. The focus, because it's opening upwards, we are going to move from the vertex 2 units up. And since up is a y direction, we're going to be adding 2 to the y. So it's -2, -6 plus 2, which is -2, -4. The directrix, because y changed, it's y equals. And it's going to be -6 minus 2, which is y equals -8. Now I want to stop for a second because some of you may be struggling with this and you're much more visual learners. I was a visual learner when I was doing these kinds of things. Sometimes it helps just to sketch it to find especially the focus and the directrix. So if you're drawing a picture, you can do just a real simple sketch here. -2, -6 would be somewhere down here. Okay? C is 2 and it opens up. So that means I have to go up 2, this is -6, I have to go up 2 to find my focus. And now you can look at the picture and see that it is -2, -4. Remember that the directrix and the focus are in opposite directions from the vertex. So to find the directrix, I would have to go 2 units down. Now the directrix will never go through the focus. It's always on the opposite side. So it's going to be horizontal. And where is it? Well, it's 2 units farther down from before. So it is at y equals -8. So for some of you, it might be easier to sketch your curve first. And that's fine. If you can do it without a sketch, great. If you need to draw a sketch, that's totally fine as well. We're going to be dealing with sketches more as we go into the assessment for this unit. Finally, let's talk about how to change from general form to graphing form. And as we have done for every single lesson so far, it is a variation on complete the square. So the big difference here is the fact that since only one variable is squared, you're only going to do complete the squared once. So let's do an example. We have y squared minus 16x plus 2y plus 25 equals 0. Now do you see how this is a parabola? I don't have an x squared term. That's how I know it's a parabola. Okay, I am going to write in red the main differences between this complete the square and the prior ones. The first one is the fact that you move all non-squared variables to the other side. Usually, the only thing that moves to the other side is the number. But this time, since x is not squared, x moves also. So in this case, it's going to be y squared plus 2y. I don't have a constant to factor out, so I'm just going to go ahead and put my plus blank. I'm ready to do that. Then the equals. The 16 moves over and turns positive. The 25 moves over and turns negative. I must put a blank on this side because the two sides must match in that department. So now we're ready to complete the square. Question that some of you may have. If I had had a number in front of the y, do I have to factor that number out? The answer is yes. Most of the time you won't have a number there, but if you do, you must factor it out. So in this case, it's going to be y, and hopefully you're getting pretty good at this complete the square thing now. The middle number is 2, so what two numbers go in the brackets below? It's 1 and 1. What goes in the blank? A 1 does. Does a 1 go on the other side? Yes, because there's no number in the front to affect it. So now we're going to have y plus 1, the quantity squared, equals. Now I'm going to jump up a line. I'm going to go ahead and combine like terms up here. So this is 16x minus 24. I want to go back for a minute to the y plus 1 squared problem at the top. Notice that graphing form has the square term on its side by itself, which I do have. Then it has a constant, a bracket, and then a single x. So when you clean up this side, no matter what number's in front of x, you got to pull it out, whether it divides evenly into the other one or not. This time it actually does not divide evenly into the other one, and that's okay. I must pull out 16, and I'm left with x minus what? 16 times what is 24? The answer is 1.5. That is now in graphing form. So let's come up with the information that we need. The vertex is going to be, think about it for a second, positive 1.5, negative 1. C, the focal length. Take the 16, divide it by what? 4. So C is 4 this time. Since y is squared and C is positive, which way is it going to open? Look back on the prior page of notes if you need to. It is going to open to the right. Focus. Focus is a point. I am going to move 4 units to the right of my vertex. If I'm moving to the right, which number do I change? I change the x. So I'm going to add 4 to my x. So my x value will be 1.5 plus 4 comma negative 1, which is 5.5 negative 1. The directrix, because x changed, it's an x equals line. It's going to be the 1.5 minus 4, which is negative 2.5. So here's my directrix, here's my focus, here's my focal length, here's my vertex. And we found everything we needed to find. All right, now for the assignment. From the Griffith book, this is section 1.7, which is on page 18. I suggest you do either the odds or the evens. Out of the Delta book, it is section 1.06, which is on page 27. Only do problems 1 through 5. Their problems are longer in the Delta book. That's why it looks like they're doing a lot less, but they're really not. So here is the assignment. We have now discussed all 4 conics. In the next lessons, we will go back and go into detail about each of these conics, talk about a few more features that they have, and a few other things that you need to be able to do with them as you go forward.